Picture a field of golden rye or wheat, symbols of nourishment, but hidden among these grains is a threat: Claviceps purpurea, or ergot. Unlike typical mushrooms, ergot forms hard, dark, curved sclerotia that replace healthy kernels. These sclerotia are harvested with the grain, blending into our food supply. Ergot is more than a simple mold. It produces powerful alkaloids with dramatic effects on the human body. For centuries, ergot has haunted our crops, thriving in cool, damp weather, and contaminating bread and flour. Its accidental consumption has caused devastation, but it's also led to medical breakthroughs. Ergot is a paradox, a deadly poison and a source of life-saving drugs. This duality makes it one of the most significant fungi in human history. Ergot's global footprint is vast. Wherever rye and wheat are grown, especially in Europe and North America, the fungus follows. Historically, poorer communities relying on rye were most at risk. The fungus's life cycle is tied to the flowering of grain, with spores infecting the plant and forming resilient sclerotia. These sclerotia survive winter, ensuring ergot's persistence year after year. Its resilience makes it a stubborn agricultural challenge. Understanding ergot means recognizing both its dangers and its potential. The story of ergot is a testament to our ongoing struggle and ingenuity in facing nature's hidden threats. From field to table, ergot's journey is a reminder of the delicate balance between food safety and scientific discovery. Its legacy is written in both caution and hope. Long before science explained ergot, people feared its effects, known as St. Anthony's fire. Victims suffered burning pain, muscle spasms, convulsions, and terrifying hallucinations. In other cases, blood flow to limbs was cut off, leading to dry gangrene, numb, blackened limbs that could fall off without bleeding. Entire communities were struck after eating contaminated bread, with symptoms so bizarre they seemed supernatural. The true cause, tainted rye, remained a mystery for centuries. People blamed divine punishment or witchcraft. In the late 1600s, Dr. Thuillier finally linked the illness to rye bread, noting the poor who ate rye suffered, while the wealthy eating wheat were spared. This discovery was a milestone in public health, connecting food to disease. Yet outbreaks continued. The last major one in 1951 in Pont-Saint-Esprit, France, where hundreds suffered hallucinations and pain after eating local bread. The event, called Le Pain Maudit, left deaths and lasting trauma, a modern echo of ergot's ancient terror. St. Anthony's fire is a stark reminder of the importance of food safety. The suffering it caused shaped our understanding of disease and the need for vigilance in our food supply. Today, ergotism is rare, but its history warns us never to take safe food for granted. The lessons learned from centuries of pain continue to protect us. Ergot's dark legacy is a chapter in the story of human survival. It's a reminder that even the most basic foods can hide deadly secrets. Could ergotism explain the Salem witch trials of 1692? That year, young women in Salem displayed convulsions, strange behaviors, and hallucinations, symptoms eerily similar to ergot poisoning. In 1976, Linda Caporail proposed that contaminated rye, a staple in Salem, might have caused these symptoms. The weather had favored ergot growth, and the girls' experiences, muscle spasms, visions, crawling sensations, matched known effects of ergot alkaloids. This theory suggests the accused weren't faking. They were suffering real physical effects misinterpreted as witchcraft in a superstitious society. Hallucinations and sensory disturbances could easily be seen as supernatural torment. Critics argue social and political factors played a bigger role. But the ergot theory remains compelling. It's a powerful example of how biology, culture, and fear can collide to create tragedy. Whether or not ergot was the cause, the idea reframes a dark chapter in American history. Sometimes, the real monster is not a witch, but a fungus hidden in our bread. The Salem story reminds us how easily nature's poisons can shape human events. Ergot's influence reaches far beyond the field. Its legacy is woven into the fabric of history. Ergotism strikes in two terrifying forms, convulsive and gangrenous. Convulsive ergotism attacks the nervous system, headaches, dizziness, then violent muscle spasms and hallucinations. Victims experience crawling sensations, paranoia, and delirium, fueling beliefs in possession or witchcraft. Gangrenous ergotism targets blood vessels, cutting off circulation to extremities. Limbs burn, turn numb, then blacken and die, sometimes falling off without bleeding. Both forms are agonizing, determined by the specific alkaloids in the contaminated grain. Historical accounts describe the horror of losing fingers, toes, or even entire limbs. The difference between these outcomes lies in the chemical cocktail within each ergot sclerotium. Ergot's effects are unpredictable and devastating. Its poison shaped history through suffering and fear. Understanding its symptoms was the first step toward taming its power. Despite its deadly reputation, ergot became a tool for healing. For centuries, midwives used tiny amounts to speed childbirth or stop dangerous bleeding, risking overdose for a chance to save lives. In 1582, Adam Lanesser documented this practice, but ergot remained too dangerous for mainstream medicine. The breakthrough came in the 1800s when Dr. John Stearns promoted powdered ergot for labor. Though dosing was unpredictable and risky, doctors soon realized the dangers: violent contractions, ruptured wombs, and harm to babies. So ergot was reserved for stopping postpartum bleeding. The real revolution began when scientists isolated ergot's active compounds. In 1906, ergotoxin was identified, and in 1918, Arthur Stoll isolated pure ergotamine. For the first time, doctors had a reliable, measurable drug. This transformed ergot from a folk remedy into a precise pharmaceutical. Standardization made treatment safer and more effective. Ergot's journey from poison to medicine is a story of scientific progress. It's a reminder that even the deadliest substances can be harnessed for good. The key was control and understanding. Isolating ergotamine opened new doors in medicine. Ergotamine became a frontline treatment for migraines, constricting blood vessels to relieve pain. Scientists developed safer derivatives, like methylergometrine, now vital for controlling postpartum bleeding. Ergot-derived drugs also help treat Parkinson's disease and pituitary tumors, mimicking dopamine to restore balance. Perhaps most famously, Albert Hofmann's work with ergot led to the discovery of LSD, revealing new frontiers in brain chemistry. Today, research into psychedelics, including LSD, explores treatments for depression and PTSD. Ergot's chemical legacy continues to shape modern medicine. Its compounds save lives, ease suffering, and expand our understanding of the mind. From migraines to childbirth, ergot's impact is profound. The fungus that once brought misery now offers hope. Its story is a testament to the power of scientific curiosity. Ergot's transformation is ongoing, its potential is still being unlocked. Ergot's story is all about dosage. In contaminated bread, its alkaloids are unpredictable and deadly. The breakthrough was purification, isolating specific compounds like ergotamine and ergometrine. With pure chemicals, doctors could study effects, determine safe doses, and avoid toxic side effects. Modern drugs are precisely measured, ensuring effectiveness while minimizing risk. Every prescription reflects centuries of progress in taming ergot's power. Even so, ergot alkaloids require caution. Doctors must consider each patient's health and other medications. For example, ergotamine isn't safe for those with heart disease. Careful management transforms ergot from a plague into a targeted tool. The poison is tamed, but its power demands respect. Ergot's journey from field to pharmacy is a lesson in precision. The line between remedy and poison is razor thin. Modern agriculture has pushed ergotism to the margins, but the threat isn't gone. Farmers use resistant grains, crop rotation, and deep plowing to break the fungus's cycle. Burning stubble and monitoring weather help prevent outbreaks. Even so, some ergot can slip through. Grain processing uses advanced sorting to remove sclerotia, ensuring clean flour. Strict legal limits and regular testing keep contamination low. Food safety agencies enforce these standards, protecting public health. This multi-layered defense is a quiet triumph. St. Anthony's fire, once common, is now rare, thanks to vigilance and science. The fight against ergot is ongoing. Safe food is never guaranteed. It's earned through constant effort. Ergot's history reminds us why we must remain vigilant. Ergot's story is a lesson in nature's duality, a poison and a medicine, a curse and a cure. For centuries, it brought fire and madness, shaping history through suffering and fear. Yet from its toxins, science has crafted life-saving drugs for migraines, childbirth, and Parkinson's. The difference is understanding, purification, and precise dosing. Ergot's transformation from folk remedy to modern medicine is a triumph of human ingenuity. Its legacy is both a warning and a celebration. Food safety and scientific curiosity are our shields against nature's dangers. Ergot commands respect, its power is real, its history unforgettable. The fungus that once haunted our bread now saves lives. Its story is a reminder. The greatest remedies can come from the greatest threats. Ergot's mark is indelible, written in both fire and healing. We must never forget the lessons it taught us. In ergot, we see the best and worst of nature, and ourselves.